classes today.
All right, so we have trig derivatives. We have log derivatives that you've seen before. What you have not seen yet is inverse trig. Now, let's be clear. It looks like arc sine, but it's like saying sine inverse of x. Remember, sine inverse of x finds the angle measurement. Remember, and we restrict it between, for sine, it's between negative pi over 2 and positive pi over 2. That's from advanced math. Okay. So all of these can be written as like cosine inverse of x, tangent inverse of x, cotangent inverse of x, secant inverse of x, and cosecant inverse of x. So you can interchange arc sine and sine inverse, and they still mean the same exact thing. Yes, Dan?
Will they ever show up like that or homework or tests?
It'll show both ways. Yeah, I try to interchange them because it depends on how College Board feels. Determines how they write it. It is typically easier to write it as an arc sine or arc cosine because it requires less effort to type. But that doesn't necessarily mean that they won't do it. Okay. Alright, so yes, you have to memorize these. And you just have to memorize your logs. And you just have to memorize your trig. And let's also be clear. At some point, we're going to start throwing in values of x with your trig, with chain rule, which requires you to still remember your triangles, your all students take calculus, your reference equals. I know. That's probably going to be the harder part, is the actual evaluation of trig, more so than having these memorized. Okay. So let's do some chain rule. That's why Mrs. Roche ran away. She knows how bad this is. The Google form sucks. I'm just gonna tell you right now. I'm warning you.
It's not like you could have not.
And let's also be clear. These are supposed to give you guys a basic idea of how to do chain rule. And then you have to go and try to apply it to your grade scope and apply it to your Google form. In the end, your grade scope, I think you can probably do while you're at home, and I think that your Google form you should probably do while you're here. I'm just saying. Okay, what's the derivative? So first of all, you have to find the inside and outside function. I can color code these. The outside function is your trig, and your inside function is your angle. Until I mess with you. I'll be the next example.
I like math.
I like math. You're like, wait, can I go back and pull out that survey again? No, it was not a coincidence that I asked this before chain rule. Okay. So, derivative of sine is cosine of something. And remember, we leave our 2x in there. And then we multiply by the derivative of 2x, which is 2. Notice that I put a extra set of parentheses around cosine of 2x. Otherwise, it looks like that 2 is being multiplied by the 2x. The 2 is not being multiplied by the 2x. The 2 is actually multiplied by the entire cosine of 2x. If you don't put an extra set of parentheses, I will mark you wrong in your grade scope. Unless you write it like this.
That's the answer. Yeah.
That is the answer. Oh, it's about brace yourself.
What happened to Mr. Anti-Jinx, sir?
I know, right? He really just jinxed the entire time. It's not gonna be that bad. And then I'm like, oh, just wait till example 2. Alright, so when you guys have thought about outside and inside functions for like literally the last 24 hours, what you started to probably see a pattern in is what's furthest outside, furthest to the left, right? And so some of you guys might think, oh, I think tangent is my outside function. It's not. Technically, tangent squared of x is the tangent of x quantity squared. So tangent squared of x is technically the tangent of x and everything is squared. Because it's tangent x times tangent x. No, so your outside function is something squared. And your inside is tangent of x. So your derivative is 2 times something to the first power. That something is tangent of x. The derivative of tangent is secant squared of x. So y prime is 2 tangent x secant squared of x. And it doesn't make any difference whether or not you write tangent first or secant squared first. Doesn't matter. Yes.
Oh, the secant squared x is just the derivative of
Tangent.
Yes. I like math.
Alright. Questions that you guys have? I know.
This is a philosophy of math.
It's worse.
So we have a lot of examples. Look at these.
Ooh, those look
Look, it's a common.
Alright. Try to slide this right. Yeah, hurry. Alright, your outside function is cosine. Your inside is the 4x minus 1. So y prime is derivative of cosine is negative sine. And that is a 4x minus 1. And then the derivative of 4x minus 1 is 4. So y prime is negative 4 sine of 4x minus 1. Sure. Oh my god, why are there so many examples? I tried to do more examples in this one because you guys, there's inverse trig, there's regular trig, and there's also logarithms. Alright, so your outside function is our cotangent. And then, oh, look at this. You got an inside function and another one. Oh, that's too close. You got 3 dolls. The more the merrier, right? What is that? I feel like I'm good with 1 doll, thanks.
What is it?
What is that?
That's Spumoni ice cream.
Well, I could have made a Neapolitan. Because there's 3. Okay. I told you you make a lot of food references.
I'm the one getting one now.
Okay, our cotangent is your outside function. Technically, it is to the 1/2 power, and it's 2x plus 3 to the 1/2 power. So I'm changing this a little bit just so that you guys are aware the fact that you have to change everything into a fractional exponent. So your outside is still arc cotangent. You have one inside to the half power, and then you have another inside of 2x plus 3. $3, not just 1 or 2. Okay, so derivative of arc cotangent is something that you don't remember yet, so you have to scroll back up. -1 over 1 plus x squared. Okay.
Oh, we forgot it again.
I know. -1 over 1 plus something squared. That something is to the 1/2. And it's your 2x plus 3. That's only doll number 1. That's doll number 1. Are we okay with doll number 1? Even though you don't like it. Okay, doll number 2 is times 1/2 something to the -1/2. That something is your 2x plus 3. That's doll number 2. And then doll number 3 is the derivative of 2x plus 3, which is 2. All we've done is we've worked our way inward. Yes. Correct. We're gonna get there. Anybody confused about the $3? I know you don't like them, but I'm not liking them. Are you confused about the $3? Now, then things happen. Then stuff happens. The 2. I need like a. Okay. The 2 and the 2 cancel out. I'm running out of colors. And my 1/2 and my 2 also reduce. So what am I left with? A big fat mess. I have y prime is equal to -1 plus 2x plus 3. I should keep this in the same color. Hold on. This is coming out of me.
You have 3, 1.
Okay, that gives me my first doll. My second doll is 2x plus 3 to the -1/2, and I have no third doll left because we
Killed it.
It is an X doll.
Okay,
It just ceased to be.
you're still not done yet. Because guess what? 1 plus 2x plus 3 gives me 2x plus 4. What? Nope.
Oh my god.
So I could have done this. I could have done -2x plus 3 to the -1/2 over 2x plus 4. Or I could have also done -2, sorry, just kidding, -2x plus 3 to the -1/2 over 2 times x plus 2. Or I could have done -1 over 2 times x plus 2 and 2x plus 3 to the +1/2 power. Or
Stop.
2 times x plus 2 square root of 2x plus 3. Now, what do I expect for your grade scope? Because your Google form is probably going to look like this. That's why I said the Google form sucks. It's terrible. Hey!
Thanks for the warning.
I'm like, and everybody breathe before we do the Google form.
Before we, not you.
Yes, question.
All those options are dumb. Why do they have to do 1 minus and square root in the denominator?
That's what College Board is. It's dumb. I'm not saying it. I'm
We love colors.
Now, as far as your grade scope is concerned, I would be totally fine with it being in the very first part, where you just multiply the 2 fractions together. Okay. Question.
Oh god. No, that
All right. See, and you're like, oh, algebra was so good until now. And then you're like, oh man. All right. Okay, so I'm gonna rewrite this as sine inverse x to the negative first power. Because who would ever want to do quotient rule? Maybe. That's a good. Yeah, maybe me. But for funsies.
Sure.
My kind of fun, not your kind of fun. See, we know why now, like everybody in the middle of COVID, like all the calculus students are trying to get me to video games, because then I would be doing stuff like this. Okay. Outside function, inside function. Okay, at least there's only 2 dots. And now, our arc sine function is 1 over the square root of 1 plus or 1 minus x squared. Okay, so So 1 minus the x, so whatever's in the argument, the angle measurement, squared, and then times the derivative of my inside function, which is negative 1 x to the negative second power. This one's not as bad as the other one. The other one was a little bit of a train wreck. Just a little. So y prime is negative x to the negative second power square root of 1 minus x to the negative second power. It can go further. I don't expect you to necessarily do that on your
Scope rating.
On your grade scope. But it can go further. Technically it can still go further. I hesitate. Technically it can still go further.
Yeah. I like math. I love math.
I can find a common denominator. And now you guys are like, now when you look at the survey question, you're like, and Mrs. Hayden wonders why we would have chosen stats. Me too. This is where algebra gets bad. Because, yes.
Oh my.
So x squared, and then this is technically x squared minus 1 over the square root of x squared. Oh, look.
Yeah, it is over. It's over X.
Just put zero.
That was less.
Look, and I can cancel out one more x.
That looks less simplified.
Oh no, I'm not done yet. Because I can cancel out an x.
We're gonna send you back to math game.
81.
81, whatever it is.
Look, it's pretty.
Show it.
How did you get there? For what reason?
I feel like you're like a fast.
Yay! It's prettier.
That was worse. You're just flexing on us. Look how much math I can do. I'm so good at math.
Look how much I know. Look how good you guys are. Good luck learning this.
And this is why we have an open working class period tomorrow. Okay.
You missed out the best.
You missed out the best part ever. It's okay, it's on the video. Yeah, watch the video, fast forward all the way to this point right here. Skip all the rest of it. Skip all the 20 minutes.
I'm gonna watch this. I'm glad I wasn't happy.
Alright.
Are you sure?
I know there's a couple people that are right now that are absent today. But again, that's why we have open working class periods. Okay. Now we gotta change gears to logs and E. So, just kidding. The outside function is E. Your inside function is your exponent. The derivative of e to the x is itself. E to the x squared. Then you multiply by the derivative of x squared, which is 2x. So y prime is 2x e to the x squared.
Is there like a time in real life where we'll have to use it? Is there like anything in real life where we use it?
No. Because you have a calculator to do it.
Why is this class not called calculator?
That's what I keep telling you guys. In the end, when I'm teaching you guys, one is problem solving skills. Two, the other thing I'm teaching you guys is real life skills. Because at the end of the day, most of this math that you guys are going to do in the future, you will have forgotten. And then you will either, one, open up the computer program that can do all of this for you, or two, you're going to look it up. Because that's what Google's for.
Or we could go back and look at our notes.
Oh yes, or you could go back and look at your notes. I know, right? You take that to your first engineering job. I have all my advanced math and all my calculus stuff.
The new CAD does all this. The new CAD do all of this.
Oh, I know, yeah.
Sorry, you're
Well, and most engineering firms hire mathematicians just to do stuff. Just to double check work.
I swear we could replace you all with computers, but they just want to keep them around. It's so bad.
Alright.
Thanks, Paul.
No problem.
Outside is log, inside is x squared.
What does that make?
Y prime is, nobody remembers the one for log, so we'll go back.
1 over
One over x land e.
1 over F.
So 1 over x, which is your x squared. Ln of b, which is ln of 4. Multiplied by your derivative of x squared, which is 2x. And guess what? An x cancels out. So you're left with 2 over x ln of 4.
We simplify it.
Simplify it.
Yeah.
No, we need to get through the list.
Alex, do not encourage her.
Alex is a massive.
I have to send you guys, I will do it today. I have to send you guys a meme that was going through my group chat with Mondragon and Maria. Mondragon sent a meme through there, and I gotta send it to you guys. So I'll send you guys a reminder. No, so there's another one. It's about composition of functions. I remembered it yesterday. I was like, oh man. All right. Again, nobody would ever want to do quotient rules, so I would change this to x to the negative third power, unless you really want to. Which we don't. So outside function is ln. Inside function is x to the negative third.
Wait, would there be a third function if there were like a squared outside of that?
Yes.
Thing?
So y prime is ln, which is 1 over x to the negative 3. Multiplied by the derivative of x to the negative 3, which is negative 3x to the negative 4. Yes, you do have to simplify this. I would first start off so you don't get confused by changing these to positive exponents. And then it would be pretty straightforward to realize that you just get negative 3 over x. By the time we get to BC, I know we're going to finish the lesson. Alright, question. Outside function is 3 to the something power. The inside function is cotangent of x. So y prime is 3 to the cotangent of x ln of 3. And then we're multiplying that by the derivative of cotangent of x, which is negative cosecant squared of x. So really the only thing that you can do is move the negative sign to the front.
Oh yeah, that's one to see about over C1. What's the one to see five?
Questions? Yes.
So on this, if cotangent was something other than x, like if it was cotangent of like x plus 3, we have to do the next one too.
Yes.
We only have to have like the double terms and there's an index, right?
Yeah. There's your little cartoon for chain rule. Well, I'll send you guys the one. It's like crocodiles. It's funny.
Crocodiles and
Okay, hold on. Let's see if I can find it. Like you're talking to my iPad. Oh yeah, here.
What?
That's what Mondragon sent to me the other day. I was like, oh, we're gonna do chain rule. It's fantastic.
How does he?